We are moving on now to our next presenter in the person of Muyisa Kambale. Hello, Muyisa, how are you?
Hello, I'm okay.
Are calling us from DRC today, Goma, if I'm not mistaken. You are the technical and commercial engineer at the company GoShop. You've been working in renewables and IT now for almost 10 years with companies such as Airtel and EcoDGEC. And your background is truly electrical and electronics engineering. And I'm really, really happy
Yes.
to welcome you today because you are going to tell us about another very important aspect of storage, another important fundamental aspect to fully understand if we want to build successful projects. So
Thank you
over
so
to you.
much. And I want just to thanks first the first presenter. It was amazing, even if I didn't see and hear all he presented. So what we have just to share together today is about the state of change calibration and battery balancing. The plan is going like this. We have just to see the introduction, the state of change, calibration, and then we'll finish with the battery balancing. There is something we have to know first before we talk about the state of change and our topic of today. The first one, we have to know that the battery store electrical energy in electrochemical form. We can see it on this opposite side that we have just here, the normal state and how the chemical reaction can happen when discharging and after discharging. And in the discharging the lead, in the anode react to give electron, the cathode made the lead oxide react with the electrolyte. So this reaction generates a current, and this is called the oxido reaction. In the discharge, the forced reaction requires application of a current on the all two terminal of the battery. So the anode, there must be a reformation of a lead oxide, and on the cathode, the reformation of the lead. And here you can see how the chemical reacted and the result of that reaction. There are some challenges we
Muyisa,
used to face. Yes.
can you please click on presentation mode so that everybody can get your slides in the widest shape possible? So presentation mode, you click next to the, yeah, there you go. Perfect. Thank you.
Okay, good. Thank you so much. So, as a use of the battery, I think that everybody knows this different problem we used to face. The first one, what we have just to know that the chemical reaction is so complex, so we'll not have a perfect control of the battery. As the energy stored in the electrochemical form is in the battery is difficult to currently determine the amount of actual energy stored in the and usable. Other time, other elements are added to the different internal reaction of the battery in addition to aging. And here we can see just the place deformation, the density of electrolyte, which will no longer be the same during the usage of the battery. It is the combination of all these elements that make the control process very complex. We will subsequently see some concept that will allow us to overcome some of these challenges. Based on the above, we are only left with a few shorting window. First, we can count the specific sensor, the quantity of amp entering the battery per unit of time. And I think that they explain it in the first presentation, that is calling the amp hour. In the discharge, the same value must be counted. The electric voltage applied on the battery terminal must always be quantified during the charge and controlled during the discharge. The concept learned in the previous presentation is necessary to understand the rest. Now we can attack this subject, which is the state of charge. Now we can see the picture here. This one represents a battery 100% charged. The second one is half charged, and the last one, the state of charge denotes the capacity that is currently available as function of the rated capacity. The value of state of charge varies between 0 and 100%. This state of charge is 100, then the battery is said that is fully charged, as we can see on the third picture here. And we can see that on the last one is said discharged completely here. When I think that everyone can see the mouse on this picture. Another concept we have to know is the concept of the DOD, which is called the depth of discharge, and can be calculated as you see here on the picture in this text. It refers to the amount of charge that may be used up of the cell if the cell is fully discharged. On the picture, the first one, you can see when the battery is 100% charged, that means that the state of charge is 100% and the depth of discharge is 0%. On the last one is just something that is a contrary. You can see here, the state of charge is 0% and the depth of discharge is 100%. On the middle is just the, on the first picture, on the second picture here, 20% of states of charge. And that means that directly the depth of discharge, the DOD, is 80%. So now, we have to know that these two parameters affect the lifespan of any charged battery. For example, on the picture here, they show us something that is more important. The remaining capacity, and on this side, you can see the circle of life. If you used to discharge your battery on 1% or on 100% DOD, you will see that your battery will just have a lifetime of 1,000 cycles. And you can see just you used to discharge it on 50%, it can go till 5,000 cycle of lifetime. That's why I think that we have to take care of how we use our battery if you want to use it for a very, very long time. So let us talk something about the calibration. This is mainly used on lithium battery. And here, the first challenge is that we have to know that the fundamental problem is that there is no reliable way to know exactly how much energy a battery contains at a certain given time. As explained in the introduction, this is an electrochemical storage system that is constantly changing and degrading and never behave exactly the same from a charger to the next. I can explain this using these words. You know, if you have a battery, you charge this for the first time, and for a second time, the third time, you will remark something that the energy storage and the restituted energy will not belong the same. And because of this, and this can imply something that we have to know, that when we have the electronic on the battery, which can give us some to let know the level of the quantity stored in the battery, must not give the accurate level of the state of charge. And because of this, the battery needs to be calibrated. Here they show us how to calibrate the battery. The first thing we have to do is just to charge the battery till it must be full. And we'll connect the charge on it. If it's a cell phone, we have just to use it till the battery will display 0%. And after, you will charge it till you will attain 100%. And then in that way, you will calibrate it. And the battery must be calibrated. So for the battery balancing, this concerns the quantity of energy within the cell. As we probably know, a battery is made of several cells. During the charge and the discharge, the cell generally don't have the same voltage. And this is due of the main factor is because of the internal resistance. So you can remark on a certain level that, as is shown just here, for example, on this picture, that there is many cells, 10 cells, and you will have one cell which is overcharged and another one which don't have enough voltage, it is undercharged. So we have to seek for a certain mechanism, and that mechanism is called battery balancing. After the battery balancing, you will remark that the cell will have the same level of current, the same level of voltage and energy, as it's shown on this picture. So this depends of the kind of battery you will use. If it's a lead acid battery or a lithium one. For a lithium one, they used to use the battery management system. It's an electronic card which is connected to each cell, and it can do many, many things, especially the balancing. For this picture represents a device which is called battery balancing, a battery balancer, which is connected to 6 batteries. And this one is a Victron one from Victron brand. And you can see here 6 batteries. This is called the common terminal, which is connected to these terminals. And then you can see the bus bar here. This is connected to the system of alarm, and you can reset the battery balance by pushing this button. So when we install, you do this installation, you will remark that there must not be a difference between the voltage on this battery and these others. Thank you so much. I think that if it's possible, we can begin the part of the questions. If there is some question,
Yes,
now
Muyisa, thank you so much.
Thank you so much.
Maybe you can please stop sharing your screen so that we will be both you and me showing on the screen for the Q&A section.
Okay.
Just click on the red button, stop sharing. There we go. Wonderful. Thank you very much. Not
My
an easy
pleasure.
topic, but I think you've done a pretty good job. Thank you very much. And I will take on some questions here. A question from Eric. When installing a battery system, is it better to fully charge the battery first up to 100% in order to make the cell balancing?
Can you repeat it, please? I'm noting somewhere.
So the question from Eric is when you do the installation for the first time, do you have to charge the battery fully first, or can you just assume that the battery is already fully charged when it gets delivered?
I think that this depends of the battery you are using. The first thing, Eric, you have to know is that the recommendation of many of battery manufacturer is that you have to charge it first, and then you can use it. There are many things. What I used to advise many installer is that they have to learn just the data sheet of the battery. Any kind of device you want to install for the first time, you have just to learn the recommendation of the manufacturer, and then you can use it. But generally, you have just in the battery domain, the storage domain, what you have to do first is just to charge it, to fully charge it. Even if you can, if you take your multimeter and you try to see if the voltage is correct, the recommendation in that you have to change it, and then you can begin to use it without problem.
Thank you. Next question from Yusuf. How does charging and discharging the battery eventually calibrate the battery? As in, like, how can you know for sure that the calibration is successful?
Okay, that is a good question. That is a very smart question. I'm so happy to hear that, Mr. Yusuf. You know, if you, I think that I will share this presentation. I want just first to apologize myself because it was, I didn't see the time pass. That's why I get within this meeting without seeing that. So what I have to respond to you have to know this. The form of the energy stored within the battery is in a chemical form, a chemistry form. So we do not have the way to know exactly which is stored in the battery. And that's why we used to do the calibration after some time of using the battery. So to know how you calibrate it correctly, you will just improve the level of accuracy of the sensors, the sensor which is connected to the display. I cannot assure you that you will have exactly the amount of the energy stored within the battery, but you will have something which is approach the exact amount of storage. Just try to follow the advice that I give. You charge first, and you use it. You use the battery completely till you will show the display. It displays 0%, and then you can use it. You can recharge it without connect anything, and you will. After that, you can see that the battery is calibrated. So another thing that I have to add, you know, now we are working with many technologies. Now, that kind of calibration are doing automatically. I saw some, I think that it was in a certain training I was received from one of our partner. They have the BMS which can do itself the calibration. Yeah.
And another question related to this from Lanfi. If you have improper balancing of a battery, what are the consequences? What is the problem really with this?
Okay. The consequence, if you have an improper balancing, I begin first to the lead acid battery. That's the main problem. The main, you have a battery and there is a certain, what can I call it? In the first battery, you can have something like 12.6 volts. In another, you have 12 volts. If that kind of problem remains, you will remark something that battery, which don't use to reach 12.6 voltage, will be the first to break down. That's the main consequence for the lead acid battery. So on the lithium battery, I think that is not the problem which used to occur in a lithium battery, because there is a certain BMS which has the principal role of the goal of the BMS is just to have a certain equilibrium. To have the same voltage in all cells, and to control other parameters like the temperature and so on.
Thank you. We have our next question from Dr. Mamoloto. Dr. Mamoloto is asking if you could please explain a little bit more the difference between calibration and equalization. These the same, two different words for the same thing, or are these two different things?
It's two different things. The calibration is just mainly mainly used for lithium battery, not for lead acid battery. So for lead battery acid, they used to do the equalization, and in some solar controller, which is called a regulator, they used to put a certain function. When you are installing and you are parametering, you are putting different parameter within the controller. They will give you a certain somewhere you can see how to send a certain kind of voltage. It may, if you have a system of 12 volts, you can see the equalization voltage can reach around 20 volts, 20 volts. And that you send to the battery, and the battery will react in a certain manner, and it can calibrate all the voltage within cells. I think that is two different concepts. The first is used for the lead acid battery, and the second one is used for lithium battery. The calibration is it mainly used for lithium battery, and the equalization is used for lead acid battery.
And maybe this next question will also highlight a difference between the two types of technologies. Question from Osagie about batteries that are already approaching their end of life in a project where the storage needs might have evolved over time. And the question of Osagie, I'm rephrasing a little bit, but he wants to understand what could be the impact of adding new batteries to an existing set of batteries that have been used and that have a different capacity. How could you explain in easy words what are the options in such a situation?
Okay, if you find yourself in such situation, what you have to do first is to never mix two kinds of batteries. This depends on the type of the technology you have to use. If you have lithium battery, there is no problem, because all cells of lithium battery are controlled by BMS, the battery management system. There is no problem. After 1 year, you can come with a new one and add in within the battery pack, and you will have no problem. So best to have another system, replace it completely, not to add. You cannot mix the new and the used battery to put it in the same system. No. The consequence is that the new one will be deteriorated.
Understood. Thank you very much, Muyisa.